Good afternoon, everyone. Thank you for joining us. My name is Marissa Waterman. I'm the Marketing Director here at the Academy. Today's webinar is titled Getting Started with Digital Water. Our Executive Director, Dr. Daniel Uther, will serve as the moderator and will introduce our speaker today. During the presentation, you'll be able to submit a question by clicking on the Q&A icon on the bottom of your screen. Before we get started, Dr. Uther would like to say a few words. Dan, how are you today?
Hey, Marissa, I'm doing great. How are you?
Good, thank you.
Well, colleagues, I'm really glad to be here with you today. First, I'd like to say welcome to everyone. Before we begin, there's a few things that I would like to share. I want to say thank you to the Academy patrons. Those are the folks that are on this slide. These are utilities and firms that provide the financial support for Academy programs, like, for instance, making today's webinar free. So thank you to our patrons. Second, I want to say welcome and thank you to Stanley. Stanley Consultants for the last 2 years has been sponsoring 4 webinars a year. These have been highly informative and well-attended events. And over that time, the Academy has demonstrated the value we bring to patrons. And Stanley has recently stepped up and joined the Academy's Patrons Program. It's wonderful news for the Academy and wonderful news for Stanley, and it shows a path for others to consider following. If you'd like to know more about the Patrons Program, please reach out to me or Marissa or any other Academy officer, and we'd be pleased to speak with you about it. And third, no pressure here, Steve. I want you to know that the audience that you're with includes folks from the Missouri University of Science and Technology. I'm here in a classroom on campus teaching public health engineering. And we just wanted to be able to share with those folks that are part of the Patrons Program and sponsoring webinars that we encourage you to host watch parties. In other words, lunch and learns or brown bag and webinar. Lots of us sit and watch our webinars from our desk. We're staring at a tiny screen without much connection with other people. And the 5-year goal of the Academy is to grow, connect, and diversify the profession. So I encourage you to organize watch parties. Your local student chapters would be interested in this. Perhaps maybe your office would be interested in this. It's an opportunity for you to gather, listen to some great information, and have some great discussion. So as Steve gives his presentation today, we'll have some opportunities. Students, be listening in because we'll come around to be able to answer any questions. And Steve, we're really excited to have you here with us today. So the fourth thing that I would like to do is introduce today's speaker. Today, we're going to talk about getting started with digital water, and our speaker is Steve Green. Steve is the digital water practice leader with Stanley. Now, Steve, I've always been told don't mix water and electricity. So when I saw the title of this, digital water, it of course made me very nervous. But I mean, seriously, I'm excited to actually hear from you, Steve. Steve has had a 23-year career in business development and project delivery in the water industry. He's helped water system owners improve their infrastructure via technology adoption and collaborative project delivery. Steve holds a Bachelor of Science degree in Bioresources Engineering from Montana State and a Master's in Business Administration from the University of Washington. Colleagues, before we begin, just a quick reminder, please put any of your questions in the Q&A function, and I'll moderate a discussion at the end as well as throughout Steve's presentation. And now, without further ado, Steve, we're grateful to you and Stanley. We're excited for your presentation, and the floor is yours. Thank you for joining us.
Great, thanks, Dan, and appreciate the opportunity. Just making sure you can hear me okay.
Yep,
we got you.
Okay, awesome. Awesome. So yeah, welcome any questions from your class there. And yeah, you're wondering, how did I convert water into ones and zeros, right? I made water digital. So I'll explain that as I go through the presentation here today. All right, so there's a little bit about Stanley. We've been in business since 1913, proudly celebrating our 110th anniversary here recently. And what's a great thing about Stanley is, you know, to be in business for 110 years and talking about technology here today. You know, think about in 1913, right? Communications and how that took place. and one-way telephone lines. They called it a party line, and anybody on there could pick up and listen in. And now we're doing live webinars. So a lot of change has taken place in that time period. And any business that stays in business that long has to figure out how to adapt, right? And look at the technologies that their clients need to adopt, and then have the services to help them evaluate and deliver those and onboard those. And so digital water's obvious part of that, as utilities look at all this data that they're generating and thinking of how do we leverage that data to make better decisions, realize efficiencies, save on electricity, chemicals, right, other consumables such as that. So that's kind of the focus of the webinar here today. So I've broken it down into 6 parts here. I'll start out by just overviewing some of the challenges that our water utilities are up against. Really applies globally. I've deliberately just kind of focused here in North America, but really it applies to any water, wastewater utility around the world. Talking about how the way we've managed water and wastewater has evolved, and how digital water is a part of that journey. And then, what is digital transformation? What does that technology landscape look like? What is modernization? How do you go about that? And then I think it's always great to look at case studies, right? Look at some utilities that have adopted different technologies, how they've gone about that, what sort of results they've achieved, and really just helps, demonstrate, right? This is not just entirely theoretical, right? There are a lot of utilities out there that have already started this journey and adopted some of these technologies and got results from it. And then, circling back, right, to that beginning of the presentation and say, all right, how has this evolved, right? As I think about my modernization journey and maintenance journey for all of my water, wastewater infrastructure, right? How does digital water play a role there? We'll take some obvious pauses during the presentation here, and Dan will facilitate any questions that come in, and then leaving plenty of time at the end. I've actually got extra case studies, just depends on what sort of questions we're going to get here, and we'll just manage our time accordingly. So modern water utility challenges, North America. This upper left, right, there's most of the infrastructure that is in the ground or in place in America these days is past its intended life. The ASCE, American Society of Civil Engineers, they conduct a infrastructure report card. They look at all categories, everything from transportation to stormwater, which includes categories for drinking water and wastewater. And so, these infrastructure scores in drinking water, barely a passing grade. Dan's sitting in a classroom there. So obviously, people want to do better than barely pass. Wastewater is not passing, right? Wastewater is flunking. So there's a lot to be addressed there. There's much competition for the capital that these utilities have just to rehab and replace the existing infrastructure, not to mention what needs to be expanded for more population growth or more stringent regulations, whatever that may be. So that kind of sets the table, right? There's already constrained capital here. Then layer on top of that extreme weather, right? And we're seeing more and more of these extreme weather events. This graphic here shows the various billion-dollar disasters that have occurred between 1980 and 2022. Nice analysis put together by NOAA, which is a federal agency. And part of it is, yes, there's more infrastructure out there, and there's more population, and there's more of it that is exposed to weather. But certainly, as you see that ramp up, right, you can't really attribute all of that to greater volume of infrastructure that exists, right? A lot of it is as our climate changes, right, and we're seeing more extreme events which cause more extreme damage. Water wastewater utilities, are at the core of that, and they have to address that, right, by upkeep and upgrade of their infrastructure. Cybersecurity is another issue, right? And we've seen, threat actors recently, even related to the conflict in the Middle East, that use that as an excuse, right, to attack some water utilities in America. So you just, you never know what could happen. There's a lot of exposure there, and so it's yet another aspect that utilities have to deal with. And digital water technologies, right, are at the core of that, because you're moving data in and out of the cloud, and there's ways to do that where it's safe and protected, and it has to be done very deliberately. And then budget shortfalls, kind of bringing all this together, right? You've got to address all these issues. There's a lot of excitement. The federal government recently has put a good amount of money towards water wastewater infrastructure, but the reality is, a major increase there. As you can see, the statistic here, if they increase that federal amount by 5x, it's really only going to make a 5% short-term impact, and we're on track to basically be coming up about 22% short. So this is a lot of the promise of digital water, is that it helps you do more with less. The data exists, right? You can then find efficiencies, mitigate risks, and focus those budgets that you do have using data to better hone these analyses and support these decisions that utilities are undertaking on a regular basis. So just drilling a little bit deeper into one of these specific issues, extreme heat is something. We're seeing warmer temperatures. We're seeing individual events, have higher temperatures, and it really affects productivity. Very nice study done by this Arch Rockefeller Resilience Center. This came out about a year ago, and essentially quantified for several very large cities around the globe, right? How many more days are there going to be where you're over a certain temperature? And so you can see the size of these circles really relates to that. And, going from 9 days above 80 to 17 days in LA, 36 days above 75 degrees to 55. So some real impacts there. Tying in a separate study that I was able to locate that is basically showing what happens to productivity for folks that work outside. And you can see there's a major loss in that work. And so these utility workers, they're particularly vulnerable. And so it's just another reason, right, that digital can help you automate. It can help you with visibility to remote operations, remote assets, and oftentimes you can, make changes and make setting changes, turn things on and off, et cetera. And just another factor that has to be accounted for with physical infrastructure, which includes HVAC and sun shades and things like that at these locations where these utility workers regularly work outside. So how has water wastewater management evolved? Historically, there's a ton of really interesting history to water wastewater. Unfortunately, we don't have a lot of time for that here today. But a couple interesting facts is the earliest cities in Europe, their focus was really just to convey wastewater away from the populace, because they believed that it was the odors of wastewater that were actually making people sick. They didn't realize that it was actually the cross-contamination of wastewater with water. And so obviously, as the science developed, it became obvious not only do we need to move that water away from our cities, but then we also need to treat that wastewater so that it's safe, so that it's not going to recontaminate our water, and obviously separating those sources. So that was kind of the original, right? First, let's convey it. From there, let's treat it. We discovered a lot of the sicknesses that people had were related to bacteria that was in the water. And so we learned how to filter it, right? We learned how to disinfect it. The wastewater side, we discovered, what impacts does untreated wastewater have on our waterways? We addressed that. We had the Clean Water Act, right? And so this is kind of that big second wave of, treating the water, purifying the water, starting to think about employee safety, and really being a completely regulated industry with standards that had to be met. This next wave really comes with asset management, where you have this aging infrastructure. Before this, everything was new enough. You just focus on expanding it, meeting those regulations. But now, on top of all that, now I have to think about, all right, what is not big enough? What is not complex enough to meet the water quality regulations? What is aging? What needs to be replaced? Things like that. And we started to discover, right, there's a lot of leaking, right? Non-revenue water. So our water distribution systems leak a lot of water. That water has a lot of investment in it, right, to centralize it, treat it, and then distribute it. So you're really losing a lot of money with that situation. Same thing with infiltration and inflow, aka I&I. A lot of water seeping into our wastewater collection networks that then has to be treated. There's a cost associated with that. And so there's been a lot of focus on, how do I reduce that NRW, that non-revenue water? How do I reduce that I&I, that infiltration and inflow? And now I think this fourth wave that we're really in the midst of right now is, realizing that climate change is really affecting our water wastewater systems. We have to make them more resilient to that extreme weather that I talked about earlier. We have to have emergency plans because these events are happening more regularly, power outages, extreme weather, or whatever that may be. But the good news, right, there's a lot of new enabling technologies that help address this. And ultimately, what these utilities are confronted with, and what consultants and tech providers are helping with, is the need to do more with less, right? There's less people in the workforce that are experienced. We're seeing a lot of retirements out of the skilled workforce that runs our water wastewater utilities. And so we have to address that as well as all these other challenges. And so climate impact mitigation and digital technology adoption, I think, are two big parts of the journey here that I'll talk about in a bit more detail. So quick pause here, Dan. I think I covered kind of the setting the table here. And I wondered if there's any questions you'd like to interject at this stage versus waiting until the end.
Hey, Steve, we're here with you. I have a student to introduce who's got a great question.
All right, go right ahead.
Hey, sir. I'm Joe Zeman. I'm a environmental engineering master's student here at S&T. I just had two quick questions based on the study you conducted. One was, what kind of scale were you looking at for the infrastructure? Was it larger scale, like say a St. Louis municipality, or was it like more so Rolla or smaller, or did you conglomerate both into those? And then my second question was, what did you kind of base the grading off of? Was it just strictly like effluent quality of wastewater, or did you have other factors that went into that?
Sure. So good questions there. So I think you're focusing in on the ASCE, grades of the infrastructure. And so just full disclosure, right? I've cited that there at the bottom of my slide. This is not a study that I or Stanley conducted, right? This is something that ASCE does on a regular interval. I don't remember when their last one is, but I think they do it every 5 years. They have a whole system they use to assess what drives that grade. And part of it is quality, part of it is quantity. I believe it includes affordability and many other factors. It's infrastructurereportcard.org. So I'd encourage you to take a look at that and really understand where we're at. Right, each state has its own score. I don't think they go down to the city level.
Okay, thank you, sir.
You bet.
Thanks,
You
Steve.
bet. You bet. All right. So back to it. That's a really good question. Thank you. So what is digital transformation? Okay, what's happened in a lot of these utilities, right, is there is a lot more sensors available. There's been a lot of innovation that has created, sensors that provide real-time water quantity, water quality data. You've got customer information. You've got automated metering infrastructure, right? All these things out there. SCADA systems, right? There's a lot more data being generated. It's being centralized. It is being utilized, but there's a lot there that's just never really tapped into. And so I would describe it as data rich, but information poor, right? Because data is just data until you translate it, and then it becomes information, and you can take action from information. That allows you to do informed decision making. A lot of our utilities, their operations and maintenance that they're doing is really driven by intervals based on the calendar, based off of a model that's 5 years old. Whatever that may be, right? It's just set and it's occurring. But data in various sensors, right, allow you then to do data-driven maintenance based on real-time conditions. And same thing with set points, right? Whether it's pump stations, water treatment, wastewater treatments, a lot of that is driven by fixed set points, but technology exists now to mine the data, to develop different types of control loops, different sorts of data platforms, right, that are then driving these set points and optimizing those in real time. So you get the best of both worlds, right? You get the efficiency without risking the compliance, right, and not taking too many chances there. And so that's the promise of digital water, and integrating the data sources, right? Better insights, better ops. Efficiency goes up, resilience can go up, you're mitigating risks. And then, I mentioned earlier, you've got a lot of turnover in the workforce now. So you're using data systems to capture that institutional knowledge that exists with some of the older, operators in the water, wastewater workforce. And then you're capturing those and translating those into these data systems, these digital systems that then can be used to train that next generation of worker. And it provides a record. When this happened last time, let's go back in the data and look and see what decisions were made and see if those were good decisions, and replicate those or improve upon those accordingly. A couple great images I've shared here. This lower right image I really like, because you've got an operator. The screen they have on the right side is really what would be a pretty traditional SCADA work screen. And so they've got that, and they're able to monitor and control the network through that interface. And then you've got data coming out of the cloud that's been pulled out of the treatment plants. It's been synthesized, and it's been developed into different recommendations. And so this operator is looking at that, is translating that, making a decision about what to do or not to do, and then can turn over here to this other terminal and actually make changes right in the system based off of that. So that's the evolution that's underway. This upper right image is another good one, and it shows taking that data in a bit more of a condensed form to what would be on this lower left computer screen, and putting that into a smartphone. And so as that operator is out and about in the plants or out with the infrastructure, they can actually look at some of those key performance indicators, otherwise known as KPIs, and use that to support whatever decisions they're making in the field. So the journey of digital technology adoption, there's a great organization called SWAN that really is globally focused to help bring awareness of digital water technologies, right, to water, wastewater utilities globally. And so they've developed a lot of really good materials, right, that just synthesize all this into a very clear graphic. So I love their wheel here. It's the value creation wheel. You've got a strategic driver here at 0. You've got your physical infrastructure here at 1. You've got your next layer, right? These sensors, tied into these control systems that I mentioned in the past there. And then you've got the, systems that bring that data together, communicate out to different people. And then you've got the systems that are, synthesizing that data, managing it, displaying it, and then, fusion and analytics, which is really a, kind of a catch-all here. You can see the definition I've pasted in here. It might include artificial intelligence. It might include machine learning. Might not be that complex, right? It might just be some basic first order equations, models, whatever that may be. But ultimately, right, you're using that layer to drive better decisions and look at what if scenarios, and doing that more and more real time. And then you've got your strategic outcome, and it's, it's a circle, right? It continues. So you can go around again. In the center there, I think the key to all digital water is that it's not just about the technology, right? It's about the people, it's about the processes. And so as you implement digital water technologies, right, you always have to be thinking it's not just the tech. I've got to bring my team along. This is the way we used to do it. This is the way we'll do it now with these new digital tools. These are our processes we had in the past. These are how we're going to adjust those for the future. Great news here is that there's a lot of very bright entrepreneurs that are bringing a lot of exciting technologies to this market. So Bluefield is a research group that focuses on the water, wastewater industry. So they've tracked new company beginnings, since 1970. And you can see, in the last 10, 15 years, right, there's really been a ramp up. A lot of entrepreneurs, bringing a lot of exciting new technologies to the markets. And so there's a lot of opportunity, right, to look at these technologies, figure out, how does that add value to my particular water utility? How do I go about adopting that? I think the flip side of that, which is a good segue to my next slide here, is then it becomes a little bit difficult, right? As a utility, you've got all these technologies out there. Some larger utilities, they do have a good sized staff, and they can, devote resources to parse through those technologies, figure out which is the right one for me, bring some of those resources to the table, go through that change management and adopt that. But there's also a lot of utilities out there that just don't have that sort of resource, but there is a lot of value here. And so, some technology providers are filling that gap, making things very accessible and easily implementable for smaller utilities. Then there's consultants such as ourselves here at Stanley that help folks with this process. And so the market really comes down to a couple of approaches, off-the-shelf products, right, where a lot of these entrepreneurs are saying, here's a particular issue that a utility has. I'm going to focus on that common need. Maybe there's a little bit of ways to customize it, but it tends to be, focused on a particular part of that utility. And they're using a SaaS model, which is a great model So basically anybody, and that's software as a service, SaaS, anybody that uses that technology and has a request, says, hey, I'd like to make this improvement, make that improvement, they're going to make that change and then they roll it out to everybody. So everybody benefits equally. So it is a good model in that way. But the challenge is then that utility. How do I compare, these different technologies? Which one is the right value for me? How do I navigate that journey? They have to bring the change management, the project management from in-house, or rely on that vendor to do so. There's different degrees of capabilities there to be aware of. And then oftentimes, these digital upgrades, there's a need for engineering services that are associated with making these changes, whether that's in a SCADA system or that's developing equations that translate this data. The right side here is completely customized systems, and so a utility could build in-house, or they could reach out to a consulting firm and they could say, hey, let's build something from scratch here, or let's make it very customized. I think the good news there is you're getting into organizations that are good at change management, project management. They've got the engineering capabilities, but the risk then becomes, because that is a bit of a custom system, call it a black box, it could sunset. The company that developed it could change ownership. They could go out of business. A lot of things could go wrong there. Upgrading it, keeping it refreshed is going to potentially be tied to hourly fees. And if there's a small customer count, you don't really get that SaaS-based model and all those benefits that exist there. So right in the middle there is really, technology delivery. You got to have your why, right? Simon Sinek has really popularized that, and really has a great way about talking about things. But you want to adopt digitally, you got to know what your why is, and then you got to think about, all right, not just the technology, right, but the people, the processes, and the technology, so that I can get to that success and realize these benefits for my utility. So in the middle here, I'm going to call it collaborative solution delivery. And so this is, whether you do this in-house or you work with an outside assistant, such as a consultant, is really to look at what are the problems I have where digital technologies can help to address those. And then ranking those off of, do they increase my resilience? Do they have an economic ROI? Right? What are those things that are really going to impact the business case of my utility? And then, once you've rank ordered that and, picking that direction, then you've got that decision to make. Am I going to use an off-the-shelf software? There's a lot of really good ones out there. Or am I going to use something open source, right? Is this something I could do, for example, with Microsoft tools like Excel, that is something very basic, or SQL Server, or Power BI, right? If you have a Microsoft license, you have free access to all those. And then there's a lot of other, open source technologies out there. There's a lot of machine learning tools, AI tools that are directly tied into a Power BI, for example. And so there's eyes that, build it versus buy it. There's a life cycle cost, calculation, comparison, risk, reward, right? There's qualitative factors, there's quantitative. So not simple decisions here, but plenty of, great practitioners in the market to help with that journey. Then you bring it together and you say, all right, I'm going to go with this, whatever that is. You've got that integrated engineering capability, and you've really harvested from both of those other boxes. You've harvested the best parts of it, right? Whether that's a SaaS or that's an open source, you've got that bigger group of customers that are going to contribute to those outcomes. You've got that best-in-class tech and continuous improvement. So I think that is a good time to just take a quick pause here, Dan, and see if there's any questions.
All right, we're here, Steve.
Hi, my name's Savannah McKay, and I'm a civil engineering major here as an undergrad. And I just wanted to ask more about how is this data being collected? Is it a population or say a group of people, or is it more like a PC collecting this data?
Yeah, sure. Very good question, Savannah. So I have to give one of those non-specific answers is that it depends, right? So it depends on what part of the utility that we're looking at, that we're trying to create value, right? Or realize an efficiency. So it could be anything from a SCADA system, which is a supervisory control and data acquisition. And so that's basically centralizing any sensor data that exists in a network. Might be water quality, might be water quantity. It could be, coming out of metering infrastructure. So each business and each house, has a meter. There's a lot of data there that can be leveraged to figure out where your non-revenue water leakage is occurring, and then, use that to prioritize some of your decision making about, which pipes am I going to replace, in which year, because they're past their recommended life. Or it could be, customer information like call centers, and, is my service, my customer service good? What are some metrics I can drive towards to improve that and reduce hold times or wait times or things like that? So yeah, good question. Thank you.
Thank you.
Thanks.
Okay. So I'll jump back into it. Um, so this is what I've developed. I've seen a lot of different sort of journeys and different steps on the journey that different technology providers, different consultants have. So I don't think the industry is really gelled and said, hey, this is like an official digital maturity model. So this is the one I've developed, and I'm just going to use this to talk through things. And, the first thing that happens is planning, right? So historically, water, wastewater utility, stormwater utility, they've typically had a water master plan. They've had a wastewater master plan. There's a stormwater master plan. If that's a city, right, they've probably got a transport master plan. They've got, Parks and Rec has a master plan, et cetera. So you kind of get the idea. Well, now there's, thinking back to just water, wastewater, let's just focus this webinar mostly in that category. There's a third entity here now, which is that digital master plan, because digital is really capable of addressing both water and wastewater, as well as that overall utility operations. And so there should be a plan, right, that has analyzed what are the potential ways I can get value out of digital, which ones make sense for me. Yeah, I've got those rank ordered. I've got that into my capital investment plan, my CIP, and I'm using that, to drive my investing decisions in parallel with my physical infrastructure, right? Upgrading, replacing pipes and treatment systems, et cetera. Next, or first kind of maturity level here is descriptive analytics. And so I'm just gonna, simplify this and characterize this as a utility that has a robust and modern SCADA system. They've got a data historian. They're certain that their metadata, right, the data characterization, everything has the same datum, the same timestamp, right? All these things are consistent so that it's available as a future resource, right? As you continue this digital journey, where you can unlock the value of that data. It's got the right redundancies, right? It's got the cybersecurity, right? It's all there. So you would consider yourself having a fully modernized SCADA system, and you've got the information and you've got the visibility. From there, right? Then you're saying, okay, now I want to start to get into that data and synthesize it in some manner and say, all right, this is going to support my decision making. There's an abbreviation that's been popularized in our markets. It's RTDSS. So that's real-time decision support system. So this really plays to that category there. Is whatever I've been able to do to reduce the data, translate the data information that supports my decision making. That's where I'm at this stage of the journey. From there, it can be a bigger investment, and you're going to create what's called a digital twin. And so, very simplified definition of a digital twin is that I've got an accurate digital representation of my physical infrastructure. So that's going to take a hydraulic model or a process model, combine it with all of my sensor data. I've got something that's very highly correlated between a digital space and that physical space. And so then I can actually start to look at different scenarios offline. I can use that to train people. A lot of things you can do with that. And it still supports decisions, right? That's what this is all about, is making better decisions that save money and mitigate risk. From there, that digital twin then really opens up a lot of opportunity with data science. And so I'm going to take that digital twin and I'm going to start to apply, whether it's machine learning or artificial intelligence, data science, as the umbrella term, and say, hey, I can actually now look at each set points in that system, and I can optimize it for efficiency, but also not take any chances with compliance, right? And kind of toe that line with the appropriate, risk factors applied, and making sure you get the right outcomes there. And so that, that final step is what a lot of utilities are very excited about. They see the value, they see the potential there, but there's no free lunch, right? You typically have to navigate this entire journey to get to that stage, right? First, you have to get your SCADA system. You have to go through and get that data cleansed and centralized and build that digital twin before you can really get those results out of data science. A lot of tech companies, have developed their niche products that focuses very nicely. It basically takes that utility through this 4-step journey, with a particular product that's typically, like I said before, a SaaS product, but bigger, more complex things that are pulling data from multiple places in the utility does tend to be more of a system that runs in like a Power BI or a broader, data platform of some sort. And so there you go. That's kind of a synthesis of what that digital journey can look like. Bottom line is that don't think just anymore of water master plan, wastewater master plan, but also either incorporate digital into those or have that third part that is that, that digital plan. So what I'll do next year is I've got a set of case studies where sharing where utilities have undertaken different parts of this journey. So you can see I've got a couple in that planning phase and different parts of this digital journey. So before I jump into these case studies, Dan, I'll just take one more pause here. This is kind of a key part of the digital explanation, and just see if there's any questions that are related to that.
We actually had a very specific question here, and so it might get down into the weeds, but it's good to kind of see where people's minds are going. So do you want to go ahead and introduce and share?
My name is Ezekiel Jennings. I'm a civil engineering undergrad major here. With the federal government in the current rollout of 5G and 5G adjacent technologies, we've seen the federal government reallocate and repurpose spectrum that's been dedicated for decades to these types of sensors and projects. How does that affect current and the rollout of new stuff when your underlying communication method could be gone in just a few years?
Yeah, Zeke, that's a really good question. I'm gonna take a pass on a deeply technical answer to that because that is not my area of expertise. But here's what I will share is that when you're looking at a SCADA system, for example, the goal is always to have the appropriate redundancies in centralizing your info as well as getting out with your controls, right? So you're controlling remote assets with SCADA. And if there's a natural disaster, you want to be sure you're going to be able to do that. And you also want to be sure you know what the status is. And so what we've always said in this industry is, redundancy, right? You got to have the right redundancy. And so you shouldn't rely on just a telemetry system, for example, right? The kind of the gold standard of a really robust and resilient SCADA system is a fiber loop, right? And the fiber loop, if it gets cut one place, you can still go the other direction. On top of that, maybe you need to have the right 5G. So here's the best answer I can give you is I look forward to when you join the workforce and you can help us answer that.
Great, thank you.
Great, thank you, Dan. Good question from Zeke. And yeah, so let me tell the story of several utilities here. I've got about 12 minutes left, so I don't think I'll go to all of these. I'll probably just hit maybe 3 or 4. And then we'll see what kind of questions there are, and I can always, go into a couple more of these from there. So this first one, this is a project that Stanley did. This is a community in Colorado of about 30,000 people. Pretty typical of a utility this size, where they have a SCADA system. Parts of it are aged or even obsolete. It's aging infrastructure, just like pipes and treatment systems. Electronic components, they age out as well. Companies come and go. Companies stop supporting certain components, and so they said, hey, we need help to understand where we're at, and we need a list of CIP projects that we can prioritize, and so we can get that modernized. We'd like to expand, right? We have certain remote sites that are in the SCADA now, but we'd like to have that more comprehensive. They have a new solar system, and so they even had us look at, right, how could we pull some different KPIs from that solar system into their SCADA so they can, they can track that and see how things are going. So there's always that nexus, right, of energy and water. So we visited this utility, went to their sites, got a sense of what all the components were, and then came up with a holistic and logical plan to go through and modernize all that infrastructure. And so, circling back here to my maturity model, right? We've conducted this number one here. Now they have a SCADA master plan. Once they enact that and complete those projects, they'll be mature here at this descriptive level, ready to continue that journey further. Second case study here. This is a project that we've done in partnership with Long Beach Water District. So Long Beach is a utility that either produces their own groundwater or where there's not sufficient supply from their groundwater, they import water, which most of that ultimately comes from the Colorado River. And so that you've seen that in the news, right? There's a lot of risk associated with the amount of that water, a lot of competing entities there, in a simple cost equation, right? It's many times more expensive to bring that water into Long Beach as compared to producing that out of their own groundwater. The issue here is, historically, there's a allocated amount of groundwater that Long Beach can access. It basically, they were never achieving that historically because there was some challenges with asset management and performance of that well production system. And so at its roots, it's really a need for a strategic asset management that is enabled with a digital tool. And there's always the people, the process side of things. What was structured at this utility is really 3 different groups, right, that address the infrastructure in their own specialty way, but less process and less interaction between those groups because all the data was in different silos. And so what we're doing with this project is really bringing together the data, translating it to information, centralizing that so that it's readily accessible by each of the bureaus equally, and then applying some key performance indicators as well as some predictions of well production, so that when they are potentially going to come up short, right, we're giving enough advance warning that they can then go and take action. They can rehab wells, they can add wells, they can do what needs to be done, right, to make sure they hit that intended groundwater production. So our team on this project was Go Agua is our digital platform provider, and then Kyle Groundwater with a deep expertise in that Southern California hydrogeology and a lot of the historic data that that Long Beach has used, to make decisions about their wells, and then basically creating key performance indicators, developing equations and predictions that would, alert these triggers to these utility owners and operators here at Long Beach, so that they can get ahead of their assets and make sure they hit these water production goals. Ultimately, then they're avoiding imported water and the extra cost and less resilience and sustainability associated with that water source. So this is a great slide from Go Agua, right? And again, these on the left side here, you've got your silos of information. What's happening here is we're bringing together the right data, making it the information in a single platform, so that you can drive better decisions. So here's, it's like any digital tool, right? It comes down to like, these are the screens, right? This is how the operators will interact. And, people and process, right? That's how we ensure success with digital technology. And so for each screen, we had a focus group of the specific engineers and operators and managers within the utility that would interact with each screen, making sure we captured their needs, making sure they're looking at it, reviewing it, getting their feedback as we draft the screen and then finalize it and ultimately take that into production. We're at about 95% complete with this project. You can see our team here. Heather in that upper right is our project champion. So she is an employee at Long Beach Water District, and this is her focus project. She has the support of her executives, right, and her whole team to make sure that this project comes together, and has really done an awesome job of partnering with us to create this, kind of first of its kind digital twin of a groundwater production system. So this is the key screen. The users would go in here, or they can see a quick status of each well and then click through. Each well is going to have its KPI type screen here. It's going to have the key parameters. It's going to track data. You can see it's actually got a 3D kind of synthesized image here, showing what's happening, some color-coded statuses. Single source of truth, right? So what's interesting is, you know, if you design a well, you implement it, that would come from engineering. That would be one well pump. But on the operations side, as time goes by, maybe the motor burns out, you replace the motor, maybe you rehab the impeller. You know, a lot of things can happen. It actually changes. What is the pump curve? What is the motor? What is the O&M manual? And that was an issue in the past, right? Because those were stuck in those different silos, and there was some confusion associated with that. And so here we've created a single source of truth. The pump curve, right? The O&M manual, et cetera, are hyperlinked here. And there's a specific place on the server system that backs this up, where those will be kept, and ensuring, right, that is the right version. Well, statistics and production, you know, you can see here the green side, there is some live data. You know, certainly a lot of these items that are currently, you know, operators go out on a regular basis and grab sample some of these details. You know, over time, right, a lot of these can be converted to sensors, you know, color, turbidity, pressure, right? These are all readily available sensors. And so there is an opportunity, right, for a continued journey here. We've started out with what's important, making sure that is, you know, kind of the threshold of live data, but certainly there's always room for continued improvement. Will asset management. So this project started with a condition assessments. So each part of the key infrastructure was evaluated on a 6-point scale. You can see that's color coded here. And again, as operators go out there and they observe any changes in the asset condition, they'll be able to update us, and then we'll have a dynamic record of those changes. And again, that allows these teams, right, to get ahead of things and keep it there. Production forecasting, right? So a lot of what I just showed you, right, that comes together, and we've developed some equations, right, that you know, predict how those wells are going to perform. Interestingly, we experimented with data science, you know, machine learning, AI type predictions, as well as just you know, off the shelf predictions that you would leverage out of an Excel type approach. And in this case, you know, found that those were actually doing a better job of accurate prediction as compared to these more advanced machine learning AI type approaches. So not always going to be the case, but you know, it kind of shows that it's always worth looking at everything out there for that best correlation. And so you can see here, you know, this allows the operators to get ahead and stay ahead of that production they're trying to achieve. Now, there's a lot of you know, water rights that are traded amongst the utilities that all pull out of this the same groundwater basin. So there's quite a, you know, complex system that was undertaken by the Long Beach team on an annual basis, right, to look at trading water rights and which are ours and which do we share. And so there was a spreadsheet that was developed over time. It had about 150 calculations. It would start with grabbing SCADA data and other data, and then, you know, bringing that into Excel, spending quite a bit of time, you know, cleansing the data, translating it, applying these 150 calculations, and then, you know, driving and actually, you know, eventually making the decisions that are made. And so one of the big, you know, wins of this project is to automate that, right? It grabs the data automatically, it applies those calculations automatically, and there's user inputs in here, and then there's, you know, things that are calculated and auto-filled, and really just, you know, allows the people that are doing this work to have less risk of human error, right? We're all human, and when we're, you know, manipulating large amounts of data, you know, we can make mistakes. So it just reduces that risk. And then because it's automating a lot of that manual effort, it frees up time to actually look at more iterations and ultimately drive better decisions, or just free up time for other needs, right, within that utility. As we talked about earlier, right, there's less bodies to go around to do the same amount of work, and the systems are getting bigger and more complex. So it's always great to just free up people's time. Then this is just, kind of a quick glance, doesn't really replace a SCADA system, but it gives you a quick glance, wells down the left, all the potential alarms across the top here, and color-coded indicators that'll give an operator a quick glance at the system so that they can drill down and see what's happening and, prioritize their day, prioritize their week about what do I need to do to increase this utility infrastructure performance and resilience on a regular basis. So, go to my third case study here, but just a quick review. That's really what I would call a digital twin, right? Getting to that predictive recommendations. We're not really applying data science in this case, but I think that is, future potential there. But really getting into that predictive recommendation so you can get ahead and make sure you achieve your production goals. So this third case study, just a quick time check here. I'm gonna pause for questions after this. So this is, there's a lot of climate data out there. There's a lot of different climate data models out there. It's a little bit harder for a utility to figure out, how is the climate potentially going to change? Give me an idea. What does that look like? And then, how do I translate that to my infrastructure decisions, right? And basically monetize that. How do I translate that into my CIP projects? And so this company is driven by, this project is driven by a company called Resilient Analytics that is essentially taking all the data from a lot of different climate data models, figuring out what's applicable on essentially like a zip code level, or a city level or a county level, and then applying that and saying, all right, what are the impacts going to be? Precipitation, days of cold, days of heat, maybe even wildfire smoke, right? Things like that. Then translating that for the utility. Again, getting back to these master plans. If I'm doing a water master plan and I have a wastewater master plan and I've got my digital, I also need to know what are my climate impacts, because I need to get that into my CIP. If I'm going to have a lot more extreme heat, then I need to maybe add HVAC to some of the places where I have electric motors, right? Like pump motors, where I have a lot of the SCADA system and all those, motor control centers, right? Things that generate heat. And I've got to keep it cool to get the best life out of that mechanical equipment or that electrical equipment. I have to start thinking about that proactively, and I have to, quantify that. Historically, we had this period where we had, what's a 5-year flood and what's a 10-year flood and a 25 and 100. But those are kind of off the table now. And it really varies by that specific county or zip code. And so I've got to get very specific there. So this is an example at a county level where they undertook that journey and said, hey, we need help to quantify these impacts. And so you can see once the analysis was complete, this was essentially a summary infographic. So, this being a webinar focused on water, wastewater, really just drawing attention to Colorado, kind of mid-latitude of the US, the amount of, hot days that they're going to experience drives a need for, cooling, upgrading HVAC systems for equipment or operator comfort or both of, 55 to 75%, right? There's a range there because this is hard to predict, but it's better than just, not knowing and not taking any action. And then, system capacity, right? This is focused with, because it's a county, it's a stormwater infrastructure, but knowing that there's going to be more extreme precip, therefore capacity upgrades of approximately 16 million. So, think of applying this to water, wastewater, right? You get an idea of some of the CIP projects that you have to plan for, right? Capacities, HVAC, shade structures where operators, typically work, whatever that may be. So with that, Dan, I'm gonna hand it over to you for questions, but let me just quickly hit my summary slide here before that. So tying it all back, right? So the evolution of master planning, traditionally, right, we're looking at what's the population change going to be? Okay, then my flow or my demand, and I have to, increase my capacities for that. And I'm looking at hydraulic models and I'm assessing my conditions. I'm looking for the leaks or I'm looking at the inflows. What do I need to rehab? What do I need to replace? Regulatory changes, right? What do I need to upgrade on the treatment side to address that? And that leads to that capital investment plan. I think, in the last 5-10 years, emergency response plans, safety, maybe there's a drought contingency, maybe there's water supply diversity. In the Northwest, you have risk of earthquakes now that weren't really understood before. So you have earthquake resiliency. Well, the modern takes all that, right? Whatever is geographically specific, and then you've got to add in, you've got to say, hey, digital modernization, what are those climate impacts? How do I quantify that? I've got to drive that updated CIP. So that's that. Yeah, good. Yeah.
Well, we got another student question, which we'll start with, and then I've got
Okay.
some from online. All right, go for it. Introduce yourself and give it a shot.
My name is Claire Shetley. I'm a civil engineer undergrad, and I worked with a company who last summer they have started like building new and improving old reservoirs throughout Colorado. And I know you kind of mentioned Boulder County earlier, but also I was wondering if you knew if they were using any of the data or any of this technology in the new reservoirs to kind of help, because I know water source has been like kind of a growing issue throughout Colorado because of the growing population. And I was wondering if they were using any of that technology in those new reservoirs.
Sure. So I don't know, to be honest, I don't know the exact projects you're speaking of or the exact reservoirs, but I can say, broadly that there is a lot of very good data, especially in water resources. So we kind of quantify or I guess categorize is the word, water supply and rivers and lakes and reservoirs, et cetera, is really kind of broadly categorized as water resources. And at the federal level, there's a lot of, well-known and widely available data, NOAA, USGS, right? They've tracked, river flows and rainfall, for over 100 years. So there's a ton of data. And then what I see, tech providers or consultants, they're really both doing the same thing, but in different ways, is they're saying, hey, I'm going to use that data to help the utility with a better system, a better decision, a better technology, whatever that may be. And then they're, figuring out what are these new ways, right? We have machine learning now, we have AI, we have all these powerful data science tools. And so let's take all that data, let's apply these new tools, and then let's come up with a better recommendation and a more resilient system. And so, thinking of your circumstance and everybody in that classroom, if I was an undergrad right now, I'd be thinking, is there like a data science class I can just go and audit it or just like add it on as an elective or something? Because, data is just a big part of our lives now. And, if you come into the workforce, and you've got the training of water, wastewater, water resources engineering, and you've got a good understanding of data science, you're going to be really in demand, and you're going to be able to come into these utilities that know they need to do something with their data, and you'll be like, hey, I know how to do that.
That's a good suggestion. That's a good suggestion. Well, we've also had some questions that people have shared online. So I'm going to pivot around where I can ask some of those as well. So Steve, this has been a great presentation. Some of the questions that came in were focused around the issue of, securities of systems. How do systems provide security so that they know that there's, what are the security implications of relying on digital? Some of the questions came in about customization, right? So exactly how far do you customize, or how not far do you customize? Like, is there a sweet spot in there? Somebody also noted, when you do implementation, a lot of folks always want to do very backwards looking, right? Like, here's how we've always done it in the past. So how can you integrate backwards with things we've done? And then one of the questions came in about, how do these models take into account decisions from more advanced models and less advanced models, like integrating these pieces together? So we can kind of take these questions, kind of, separate them out and kind of discuss them. I also had one on the case study that I want to get into, but maybe we'll just kind of take them one by one. But I thought if I kind of laid them all out for you at the beginning, you can kind of get your mind around kind of what's coming. Does that help?
Yeah, that does help. Thank you. Yeah.
Fantastic, fantastic. So first question that we had is, can you speak a little bit to the security implications and the risk of failure for these digital management systems, right? If we're relying on them for operation, and how do we mitigate against those potential risks of failure?
Yeah, really good question. And that is a very common concern, so I think it's good to get that out there. A couple things to talk about there. Number one is that, it's always important to protect the data where it's going, right? So to leverage a lot of these tools, right, it does require the cloud. Okay, and so when you're going from your premises system into the cloud, it's very important to protect that in the right way. The technologies that do so are there. The cloud providers that are, very cyber secure there, right? We use those in our daily lives. So all the pieces are there. It's really making sure that your whole system can handle that, right?
Okay.
And knowing what data is okay to put in the cloud and what is not. And then when it comes back, right? And that's sort of like, it's that question of, is the digital system running the utility or running whatever, system, or is it advising? And at this stage in time, pretty much everybody is just saying, hey, it's going to advise, but it's not going to take control. So what does that mean? Think back to my one photo I shared, and you had the guy that had his SCADA system to his right, and he had his data system to his left. And so he's looking at that, and he's using that to support the decision that then he turns, and he is the air gap, right? He is that safety mechanism, he or she, because then they're saying, hey, now I'm going to actually say, yes, I'm going to do that, or no, I'm not, for whatever reason. Certainly as time goes by, different entities, they might say, hey, I'm comfortable to automate that. But, I think you've always got to keep that. It's like, every pump station or every treatment plant you go to, there's a hand off and auto switch, right?
Sure.
You got to keep those, right? You don't want to get rid of those because you never know what's going to go wrong. You still need a person to drive out there or walk out there and say, I'm going to turn this on, and I'm just going to sit here and operate it until whatever's wrong with that auto is corrected.
Okay, makes sense. And so so next question was kind of on the scale of customization, right? So, there's like the out of the box, there's like the homemade, there's the homemade on site, there's the homemade by, a consultant that comes in the hourly. Is there any kind of like sweet spot you would recommend or experience you've got kind of a sweet spot in there?
Yeah, I think there's not a sweet spot because every utility is a different size and they're at a different point in that digital journey. And they've got a different set of resources, right? They've got in-house people, they have, their budgets. And so that all comes together to say, all right, what is my most acute issue? And then, like any investment, you should be making a really good business case analysis to say, okay, here's the cost of it, here's the benefits, and there's economic benefits, and then there's mitigation of risk, right, which can be a little bit harder to quantify, but yeah, it can be quantified, and you teach that there at your university, right? And there's qualitative and there's quantitative, and so just do a good job and drive a set of potential digital things, right, that you think are going to add value, and drive it through that screening, and then decide like what is the priority, and then take it as far as your budget allows, right? Maybe that's a lot of customization, maybe that's off the shelf, maybe that's in between, right? It's very subjective.
And does that change kind of with size of utility? I mean, of course, there's the larger utilities out there versus a smaller. Does that mix of off the shelf versus customization? Again, we got a lot of folks that are in the practice space, right? So as we go, kind of to a smaller, is that become a little bit more kind of off the shelf in a sense because just, not the resources on site to be able to do it themselves, or thoughts about that?
Sure. So again, it's going to be subjective, right? Because if you take like a SCADA system, it's hard getting around the fact that SCADA systems need to be custom for each utility because there's always a starting point, right? And you don't want to just replace everything. You want to try to reuse what you have. So I think those are going to tend to be pretty customized. If I take, say a pump station and I say, hey, I want to optimize this, there's going to be some off-the-shelf stuff that is proven, right? Even treatment plants now, there's a lot of similarities, from plant to plant. So there's getting to be some really good off-the-shelf things. And then, you've got to get all the systems that feed those and get those to work. And, there's going to be engineering there, right, to get that data assembled. So, it's a subjective journey. What I observe is that, the biggest utilities, they're going to be able to afford, some project manager, change manager type roles. They're going to be able to have, data science people that are, that's all they do, right? And so they can do a lot more custom things as you work your way down to the smallest utilities, right? The absolute smallest, they might need, I need something that runs on my cell phone, right? It's an app, right? Even it's something on my desktop may be too big or too expensive, right? And then everywhere in between. So yeah, hard to be specific there.
Well, and how about the backward compatibility versus the, kind of forward thinking digital twin transformation? Kind of where's Stanley's experience been working with folks in terms of, are there some there's some exemplars we point out to on the ends of the spectrum where it's kind of like, it took a while, but this one finally worked and we really gained from it. And hey, this one was really much a leader and an early adopter, and they saw where some opportunities were there. Do you have any kind of Stanley examples you'd point us to or thoughts of what you've done?
Yeah, sure. So, the Long Beach example that I shared is a good one because they had basic digital tools, right, that they'd already developed, right? They had Excel spreadsheets that were very complex that, did a lot of conditional formatting, did a lot of things that really drove a good decision, but it wasn't that there was human error risk, and there was time consumption, right? And so we just took that, it's backwards looking. We just said, hey, let's modernize that and let's combine it, right, with the rest of this digital tool. And so I think that's where most utilities are. Like, I can even think of, when I entered the workforce, I was doing things in Excel that, people I worked for that were, a generation or two ahead of me were like, wow, like that's really amazing, things you're doing in Excel. And I just kind of thought, well, gosh, I learned this in like a 300 level class,
Right.
right? And that's a continuous process. So I've worked with some young engineers that are like, we can just run that data through a little machine learning thing. I can just write it and then we'll cleanse that data and then we'll do this and make a better decision. And I'm, wow, that's awesome. And that just continues, right? That's a continuous process. So I really
Well,
enjoyed the questions I got, from your class. And
I
as you
think they
saw,
were great. I
yeah.
mean, I remember, in my own training being in a small town and, those operators, they could kind of, from the look of the clouds, they knew what they had to do, whether it was dose coagulant because they were going to get some heavy rain and it was going to affect the surface water, or, move the sludge up to the aeration tank instead of the clarifier so they didn't get stuff blowing out with the rain. And, one of the questions that folks had was this idea of the weather forecasting and how much, because I mean, it seems like those experienced operators, they kind of have it's almost like a sixth sense, right? They know,
Yes.
they seem to know so where do you bring, weather.com and drop that in effectively? Do you have some examples? Because of course, when we're thinking climate, of course, climate, we're looking at much longer trends, but we're looking at, hyper variability and unanticipated weather phenomenon, at that local scale. So where has weather been integrated into this very well?
Yeah, great question. So weather forecasting has become much more specific, right, to a smaller and smaller area. And so there's these new things, they call them hyper local rainfall forecasts. So they're basically on a 1 square kilometer prediction.
Wow.
And so a lot of these digital tools that are focused on the operational side of water, wastewater, it all starts with precipitation, right? Especially if it's stormwater or wastewater, you're going to say, hey, I want to get my treatment plant ready. I want to predict what that flow is, right? Because then that lets me predict my electricity need and what do I need to do with my biology and what chemicals and even staffing, right? I mean, it could be a lot of stuff. And so, weather is eyes integrated. And then there's some questions about water resources and, how high does a dam need to be? And, how big does a spillway need to be? And right, it's all converging, right? And there's a lot of really good data. A good anecdote is, you're talking about the operators that have that sixth sense. I've been around operators where, they give you a tour of their treatment plant and they'll walk by a pump and they'll stop and they'll just kind of,
It's the hearing.
and they're like, that pump, something's up with that pump. Like it doesn't sound right. And they know that because they've been there for a couple decades and they know the last time it started sounding like that, it failed like 2 weeks later.
Right.
And then they'll say, hey, we need to refurb that. Okay, that's awesome. But when they retire, right, how does the new person, they haven't trained their ear. And so there's sensors, right? There's companies out there that have developed sensors that, sense vibration on a pump. Some use audio, some use both. And you can set those near a pump and then you can, integrate that into your data dashboard. And, that's another flag that operator can sit there and say, hey, I'm seeing this issue and this issue. They correlate. And so I'm going to go do something about that pump.
Yeah.
It's all out there. It's a journey.
Well, I know the students sitting here in the room have thoroughly enjoyed, because it's so fun to hear somebody with some experience, but talk this through, right? Because I mean, if we're teaching something in class, it kind of becomes, the textbook problems, right? Whereas so thanks for being a good sport as we grow, connect, and diversify the Academy. Again, like I encouraged at the beginning, we certainly do want folks to have more of these kind of like watch parties, whether they're with students or whether they're in the office. It is this brave world of hybrid events. And Steve, you were such a great sport to let us integrate some of these questions from students in here with your presentation. Just so grateful for you and Stanley for supporting this webinar today. Thank you.
Yeah, you bet. No, I enjoyed the structure, Dan, and I think you should do that every time. I really like the student questions.
Appreciate that.
Yeah.
Well, I guess we'll turn it over to Marissa to wrap up. Thanks again, Steve.
Excellent. Thanks, everyone, for all your questions, and thank you to Steve for sharing your knowledge with us today. We have several webinars planned in the near future, so you can go to aaees.org/events to reserve your spot. And just a reminder, if you're not yet an AAES member and you're considering joining the Academy, please email me to discuss our membership options. Also, we'll be sending our PDH certificates for this event sometime this week. And that's all for now. We enjoyed being with you today. Thank you so much and have a great day, everyone.
Thank you. Take care.